All right, welcome. Let's do some polar curves practice for Cal BC. Okay, so we're going to sketch the point in polar coordinates and find the corresponding rectangular coordinates. Okay, we're just going to do this real fast. Okay, 4 units away from the origin along 5 pi over 6. We know 5 pi over 6 is almost all the way to pi, so I'm going to say, all right, it's about there. Okay, that's my sketch. That's going to be good enough. I'm going to find the rectangular coordinates. X equals r cosine 5 pi over 6, which is going to be, all right, I think I may have overcommitted over there. I'm going to bring in something a little thinner, maybe in red. Okay, 5 pi over 6, to just draw the triangle to figure out what cosine and sine are. That's a 30, 60, 90 triangle. So the short leg is a half, the long leg is root 3 over 2. It's going to be negative, though, because I'm over here where x is negative, and the hypotenuse is going to be 1. So cosine is negative root 3 over 2. So 4 times negative root 3 over 2 is negative 2 root 3. And then y is going to be 4 times the sine of 5 pi over 6, which is going to be, okay, 4 times the sine is a half, opposite over hypotenuse, so that's 2. Okay, so negative 2 root 3 and 2. Okay, this one is negative 1 units from the origin along the line theta equals negative 2 pi over 3. Okay, well, negative 2 pi over 3 would be down in the 4th quadrant, but we're going to go backwards, so I know I'm going to be up here in the 2nd quadrant again. Okay, so negative 2 pi over 3 would be down here, you know, pretty steep. So this one's going to be pretty steep up here, except it's just going to be 1 unit away from the origin. And, okay, well, this is just 2 pi over 3 is not in the 4th quadrant. I'm realizing now. Okay. It's all right. Right, that's positive 2 pi over 3, so negative 2 pi over 3 would be down here, and so I'm going to be up here at positive 1 pi over 3. Get that out of there. And we know the coordinates of pi over 3 on the unit circle. This is a 30, 60, 90 triangle, so the short leg is a half. So x equals 1/2, and y equals positive root 3 over 2. Okay, because it's 1 unit away from the origin. It's just, I was going that way, but I went backwards 1 step. Okay. Rectangular point coordinates of a point are given. Find 2 sets of polar coordinates for the point. All right, 1 and negative 1. So that's in the 4th quadrant. 1 and negative 1, right here. Okay, this distance is going to be the square root of 2. Okay, so r equals square root 2. Theta could be negative pi over 4. You could call it 7 pi over 4. Also, maybe I'll use both of them to write 2 sets of polar coordinates. Okay, so negative pi over 4. So on one hand, I have square root 2 negative pi over 4, and then I can always add 2 pi and be at the same spot, right? Add 2 pi to theta, not to r. So square root of 2 and 7 pi over 4, and that'll be good for us. Okay, negative root 3 and negative 1, so that's going to be over in the 3rd quadrant. Okay, let's draw the sketch. Negative square root 3, negative 1. All right, well, let's see, r is 3 plus 1 is 4. The square root of 4 is 2. All right, so I've got radius of 2. And, well, this point that would be half as far away from the origin, or I'm not sure if it would be half, but like say I divided both of these by 2, I'd have root 3 over 2 and negative 1/2, right? Which our unit circle stops for a pi over 6 or a pi over 3. But I know if it went farther this way than it went down, that's going to be a pi over 6 because it's close to the x-axis. And that'll be 7 pi over 6. Okay. Another set of coordinates for this would be r equals 2 and theta equals 7 pi over 6 plus 2 pi. So I'm going to add 12 pi over 6, which is 2 pi, and I'll get 19 pi over 6. Okay. And that's 2 sets. All right, use a graphing calculator to graph the polar function and determine an interval theta over which the curve is traced only once. So, all right, this is really getting you ready for the next thing that we're going to do, finding the area inside of these polar curves. But I'm just going to go in here, 3 minus 4 cosine theta in polar mode. Make sure my window's good, 0 to 2 pi, yeah, kind of standard window. And it looks like, well, okay, we're tracing, and this time I'm going to do the pi over 24 trig. 1, 2. That was 24 pi over 24, so it's going to be 2 pi. Yes. And you can even see theta equals 6.28. That's 2 pi, and I ended up at that same -1, 0 spot that I started at. Okay, so this one takes 2 pi. Okay, 2 sine theta, that's one that I told you in the lesson traces out on only 0 to pi, but maybe we can show how that goes. 2 sine t. Okay, there we go. I'm going to zoom in on this real quick. Yeah, that's perfect. And so trace theta equals 0, y equals 0. I'm going to try something different this time, though. I'm going to put in value, and I'm going to plug in pi. And then I get back to where I started. Okay, if I plugged in pi over 2, and I'm just doing value, theta equals pi divided by 2. And I'd be up at that point. So it is, at 0, it started there. At pi, it's back here, but pi over 2, it's up there. That's telling me it traces on 0 to pi. Okay. This, I'm pretty sure if this was a thing you needed to find the area inside, you would probably be able to, hold on just a second. It would probably give you the balance of integration, I really think. I don't know what this is going to look like. We're Windows 0 to 6.28. I'm going to zoom standard. Okay, 2 pi is not enough. Yeah, and so that actually, I feel like maybe I'll try 3 pi, right? Maybe I'll just add more pi. So 3 times pi. That's not enough. So I'm going to do 4 pi. And that looks like it was good. Okay, so we start out theta equals 0 here. Okay, I'm going to calculate a value where theta equals 4 pi, because I know you don't want to click the right button 24 times 4 times. That's 96 clicks, right? We don't want to do that. Oh, pardon me. What did I say? Theta equals 4 pi. What's the problem there? Okay, sure, whatever. We got back to the point where we started, 5, 0. And so I'm thinking that's 0 to 4 pi. Okay. And 3 plus 2 sine theta, I think that's gonna, well, I don't know. I can't remember. 3 plus 2 sine theta. Okay, it traced itself out. Let's see where it starts. It starts off on the x-axis over there on the right side. Let's calculate a value. We'll do pi. Okay, I think it's going to be 2 pi, so we're going to calculate another value, and we're going to plug in 2 pi. And it took me back to where I started. Yeah, so this one was 0 to 2 pi. Okay. Find the slope of the tangent to the polar curve at the given r value. This is going to take more room than I have given you here. Okay, don't try to do this. Don't try to cram it in here. That's unbecoming. Put it on the back side. Okay? If you're watching this, please put your work on the back side. There's going to be product rule and stuff on this. I don't want to see you squeezing work in. I'm not going to say. I can say anything inflammatory, but you know you're better. Okay, so, number 9. R equals cosine theta. And we want to know dy dx at 7 pi over 6. All right, so we know it's y prime over x prime, so I need to get y prime. Y equals r sine theta, so that's cosine theta sine theta. This is the type of thing that if you wanted to hit it with a trig identity and you know what this is, half of sine of 2 theta, then you go ahead, right? Makes it easier to take the derivative. But if you don't, you're just going to take it using the product rule. So I'm going to take the derivative of, maybe I'll start with sine theta and leave cosine the same. Then I'll have 2 powers of cosine theta. Then I'm going to add in, leaving sine the same, taking the derivative of cosine, so it'll be negative sine. and I'll end up with 2 powers. And this looks like something you want to be able to do. You want to say it's 1 or negative 1 or something. It's not. It's cosine of 2 theta, but we don't need to go there, so we're just going to leave that as it is. Okay, and then y prime at 7 pi divided by 6 is going to be, all right, I need to draw a triangle. I'm going to do it up here. I think I may have already done 7 pi over 6 in this video. Okay, so this is negative 1/2. This is negative root 3 over 2, and that's 1, right? Because it's a 30, 60, 90 triangle, and I know the short leg's a half. The longer leg is root 3 over 2, and the hypotenuse is 1. Okay. Cosine squared would be root 3 over 2 divided by 1, or negative root 3 over 2 divided by 1 squared. So it would be 3 over 4. Minus sine squared would be, well, negative half squared is positive 1/4, and that's equal to 2/4, or 1/2. Okay. All right, so I got y prime. Let's get x prime. X prime, I'm not ready for. I need to write an expression for x before I can take its derivative. Okay, so I've got cosine theta times cosine theta, because x is r cosine theta. So I know that's 2 powers of cosine. X prime is 2 times cosine theta to the first power times the derivative of cosine theta is negative sine theta. Okay. And then x prime of 7 pi over 6 would be negative 2 times cosine theta is negative root 3 over 2 times positive sine theta. I took the negative and put it with a 2, and that's negative half. Okay. And in total, that is a negative 2 root 3 over 4, or root 3 over 2. Yeah, I think these just cancel off to make 1, and that's all I'm left with. Yeah. So, dy dx equaling y prime divided by x prime is going to be 1/2 divided by negative root 3 over 2. And there's all sorts of ways you could simplify that. I'm just not going to. That'll be my way of simplifying. Okay, number 10, r equals 1 plus 3 sine theta. Okay, x equals r cosine theta, so I'm going to distribute in the cosine theta to both of these terms. Okay. And then I'm going to take the derivative. And I'm interested in dy dx at theta equals 0, so I might throw that in here too. Okay, that's what we're looking to find. X prime is negative sine theta plus 3 cosine squared theta, using the product rule, minus 3 sine squared theta. And x prime of 0 would be sine of 0 is 0. 3 times, well, cosine of 0 is equal to 1. So I square 1, I'm still going to have 1, so it'll be 3. And then sine of 0 is 0, so this is also going to be 0. Okay. That's good. Now I'm going to do the same thing with y. Y equals sine theta plus 3 sine squared theta, but I might write it like that to make it a little easier to take the derivative of. A little more obvious what I should do. Take the derivative of theta is cosine theta. Then I'm going to deal with the outside before dealing with the inside. We're going to multiply by the derivative of the outside by the derivative of the inside. So that would be 6 times that thing to the first power times the derivative of that thing. And the derivative of that thing is cosine theta. And we leave the inside the same. Okay. And then when I plug in 0, I'm going to get 1. Plus 6 times 0 times 1 is going to be just 1. Okay. So now dy dx at theta equals 0 is going to equal y prime over x prime 1/3. Okay. Number 11, r equals theta divided by 2. I might write that as r is 1/2 theta. And we want dy dx at theta equals 3 pi over 2. All right, so I've got x equals r cosine theta, so 1/2 theta cosine theta. Y equals r sine theta, so that's 1/2 theta sine theta. All right, so I'm going to use the product rule, take the derivative of this one first, leave that the same. Then I'm going to add in, leaving 1/2 theta the same, taking the derivative of cosine theta with respect to theta, and that's negative sine theta, so I'm leaving that the same. Okay, and then I'm going to plug in 3 pi over 2. Okay, at the point where theta is 3 pi over 2, we are down at the bottom of the unit circle. Okay. And that's where sine is -1 and cosine is 0. So 1/2 of 0 minus 1/2 of theta, with theta being 3 pi over 2, is going to be 3 pi over 4, times sine theta was -1. Okay. Now I'm going to take y prime. Same situation. Product rule, take the derivative of the first factor, leave the second factor the same, then add in, leaving the first factor the same, taking the derivative of the second factor. Okay. Then I'm going to plug in 3 pi over 2, knowing that here sine is -1 and cosine is 0. And so that's 1/2 of -1 plus half of theta is 3 pi over 4. Cosine is equal to 0. And so I've got dy dx is y prime over x prime. And that is a number, and that's going to be a safe place for us to stop. Number 12. This one just keeps going. R equals 3 sine theta minus 1. Then I want to find dy dx at the point where theta is pi. All right. So x is equal to r cosine theta. And so I'm distributing cosine theta, so I'll have another cosine theta here. Y is equal to r sine theta. Okay, I know I'm thinking of this as sine theta with parentheses around it and square on the outside of the parentheses. Okay, so x prime is, take the derivative of that, leave it the same, 3 and 2 powers of sine. Okay. Then take the derivative of cosine and leave sine the same, that'll be minus 3 cosine squared. Is that actually what I wanted? No. Because, yeah, the derivative of sine is cosine. I was like, that did not look right. So it's just going to be, that's going to be the negative. Because I got that when I took the derivative of negative sine. I don't know what I said before, but I did not write it down right, that's for sure. And then the derivative of negative cosine would be positive sine. Right? And then x prime of pi. Okay, we know that at theta equals pi, we're over here at the far left edge of the unit circle where cosine theta is -1 and sine of theta is 0. So anything with sine theta is going to be a 0 in it. Okay, so that's a 0 plus 3. But if I take cosine, which is -1, and I square it, I'll get +1. Okay, plus sine theta was 0. All right. Y prime, take the derivative of the outside, that's the square. Leave the inside the same, that's sine theta, and then multiply by the derivative of the inside, which was sine theta, okay, cosine theta. And then the derivative of negative sine of theta is negative cosine theta. Okay, I'm going to plug in pi, and I'll get 6 times 0 times -1 minus -1. Okay, and that will be 1. Okay. dy dx, which is equal to y prime over x prime, is going to be 1 over 3. Sheet of paper was not done. Got plenty of room on it. All right. Number 13. 3 theta squared. Okay, that might be interesting. Theta is 4 pi over 3. Okay, r cosine theta. Y is r sine theta. Okay, x prime, take the derivative of this thing, 6 theta, leave that the same. Then add in, leaving 3 theta squared the same. The derivative of cosine is negative sine. Here, same thing, 6 theta. Leave sine the same, then add in, leaving 3 theta squared the same. The derivative of sine is cosine. And all right, we're ready to plug in 4 pi over 3. But we might need to do a little bit of unit circle work. 4 pi over 3 is pi over 3 bigger than pi, and we know pi over 3 is that first 60-degree angle. So it's going to be down here, making a 30, 60, 90 triangle. Okay. And I'm going to have, okay, short leg is a half, long leg is root 3 over 2, hypotenuse is 1. Both the cosine and sine will be negative because I'm in the third quadrant. Okay. Now, all right, 6 times 4 pi over 3 is 6 over 3 is 2, so that's 8 pi. Cosine was negative a half. Minus 3 theta squared. Ooh. Sine theta was root 3 or negative root 3 over 2. And yeah, I'm not going to be simplifying this. And then y prime. I'm not sure I'm going to be able to fit y prime in the amount of space I've got left, so I think I'm just going to start over down here. Y prime of 4 pi over 3 is going to be 6 theta. Again, that's going to be 8 pi times sine theta was negative root 3 over 2 plus 3 theta squared times cosine theta was negative half. Okay, so, get ready for it. dy dx is y prime over x prime. And that is 8 pi negative root 3 over 2 plus 3 theta squared times negative 1/2, all divided by 8 pi times negative 1/2 minus 3 times this thing squared times negative root 3 over 2. That one was pretty bad. It was probably about as bad as it could get. All right, there's 2 more of these, and they look like, well, at least the first one looks like it's going to get a little better. So 14. R equals cosecant theta. I'm just going to immediately write that as 1 over sine theta. Okay, that's a horizontal line. Y equals 1. But we're interested in dy. Oh, yeah, and so, yeah, I remember. The point of this exercise is, okay, we know r sine theta equals 1. That's y equals 1. That's a horizontal line. So dy dx should equal 0, regardless of the point that they're asking. They're saying theta equals pi over 4, whatever. Okay, we should be able to find dy dx and show that it's equal to 0 without changing the rectangular, right? X equals r cosine theta. So, well, if I took this and multiplied by cosine, I have cosine over sine. That's cotangent. Okay, so x prime is negative cosecant squared theta. And yes, you do need to know that. And y equals r sine theta is 1. So y prime is equal to 0. At pi over 4, this is not existing. Okay, that's interesting. What about when sine theta equals 0? I guess that's r is not existing there, but otherwise it's the line y equals 1. So it's y equals 1 with a bunch of holes in it, which is, never thought about that. But okay, x prime is non-zero at theta equals pi over 4 because, sine of pi over 4 is not 0, and so negative 1 over sine of pi over 4 squared will be non-zero, and so y prime over x prime will equal 0. And the places where x prime is 0 is, I think, going to be the places where there's a hole in the graph anyway. Okay. That's nice. It's a little better. No product rule here. Number 15 is r equals 1 over theta. Yeah, I was expecting one of these. I want dy dx at the point where theta is pi over 2. Okay. This is going to involve the quotient rule, right? So x equals r cosine theta, and y equals r sine theta. Okay. We'll be able to do this. So x prime, bottom, times the derivative of the top, minus the top times the derivative of the bottom, divided by the bottom squared. And y prime is going to be bottom times the derivative of the top, minus the top times the derivative of the bottom, divided by the bottom squared. Okay. And now I'm going to have x prime of pi over 2. Okay. Okay, at pi over 2, sine is 1 and cosine is 0. So sine is 1 and cosine is 0. I feel like I said that backwards. But pi over 2 times 1 minus the cosine, which is 0, over pi over 2 squared. And y prime is going to be, I think, kind of similar, but okay, cosine is 0 at pi over 2, so that will all go 0 minus 1 over pi over 2 squared. Okay, y prime divided by x prime is going to be, okay, this one I might actually say, all right, this is just negative pi over 2 on top, and so the pi over 2 in one of those powers would be able to cancel, but actually maybe not. Maybe I'll say negative 1 over pi over 2 squared divided by, yeah, I think I am. This is negative 1 over pi over 2. Okay. And I might do a little bit of simplification here. Okay, negative 1 over pi over 2 squared, well, that would be pi squared over 4, but it's 1 over that, so it's going to be negative 4 over pi squared. Times flip and multiply. Okay, well, this is equal to negative 2 over pi. And I'm getting 2 over pi. But all that was not necessary in a free response setting. Okay. There's a lot of drill problems. But, you know, if you felt like that was something that you needed work on, you know, product rule, derivative rules, unit circle, any of that stuff, that was good practice, right? It was not just busy work. So, for a certain polar curve r equals f of theta, it's known that dx d theta is that, and dy d theta is this. What is the value of the second derivative of y with respect to x both times at the point where theta equals 1? All right, I'm gonna make sure I remember putting this on there. It was like, I think it was 2 school years ago, and pretty sure you do it the same way that you do parametric. And I also remember talking to somebody about this, a lady who has taught this class many times, and she said that she has gone in and talked about, you know, concavity of polar curves and also arc lengths of polar curves in her class, but, you know, said that she'd never seen it on there before. So I'm just going to kind of quickly scroll, make sure, yeah, we're going to just take the derivative of dy dx and divide by x prime, okay, just like we did with parametric. So we're going to use the calculator to take the derivative of dy dx, though, right? So we're going to take the derivative with respect to theta of dy d theta over dx d theta at the point where theta equals 1, and then we're going to divide by dx d theta at the point where theta equals 1. And this is going to be just one big calculator event. So we're going to go over here. We're going to definitely switch the mode out of polar mode and into function mode. And I'm going to just put dx dt or dx d theta, whatever you want to call it, cosine theta minus theta sine theta. and dy d theta is 1 sine theta plus theta cosine theta. Okay, great. And I'm going to just start by taking the derivative with math 8. I'm going to put in a fraction bar. Wait, no. Yeah. Now I'm going to put in a fraction bar. Whoops. Fraction. And dy d theta, I put in y2 divided by dx d theta, I put in y1 at the point where theta equals 1. I'm going to get that. Okay, and then I'm going to divide that. Actually, maybe I'll just store that number into A. I know that's really, really paranoid, but, you know, I just learned, I realized I made an error, I think in the previous homework solutions video where I was using y1 multiplying, and I didn't put y1 in parentheses, and I'd never known that was an issue. And then, you know, of course, one of the students told me that it was because the function was evaluating when it saw the parentheses next to y1. Okay, so I'm being very careful here. So now I want to take, okay, dx d theta equals 1. Well, that's y1 with 1 plugged in, and I get that. So I'm going to divide A by the answer, and I'll get negative 109. Just make sure that's what I got last time. Yep, negative 109.828. Which I guess means it's really concave down. I don't know. Not worth trying to, you know, recover r of theta from that and see. All right. If the line tangent to, oh, so I did have one of these problems on there. I put something like this on the extra practice for this, but I'm glad to see that I put this one on here. Okay, the tangent line to the curve is vertical. Okay, that means that x prime equals 0 while y prime is not equal to 0. So x equals r cosine theta, but r is f of theta, so I might just turn that r into an f. And say, all right, x prime equals, take the derivative of f, leave cosine theta the same. Then leave f the same and multiply by the derivative of cosine, which is negative sine. I usually remember not to put in the plus. Not that time. F times sine theta. Okay? And so when I plug in pi over 6, that had better equal 0. So f prime of pi over 6 times the cosine of pi over 6. And let's do some unit circle work here. Pi over 6, kind of the first stop. So that would be a half, this would be root 3 over 2, and that would be 1. So cosine, being adjacent over hypotenuse, is root 3 over 2. Minus f of pi over 6 times sine of theta, which is a half. That needs to equal 0. Okay, that's this one. Right, yeah. Okay, this one must be false because I think that's the opposite, right? I think that's probably what you would get if you were doing r sine theta. Maybe not. Okay, but I know this one must be true and the rest of them not necessarily because this was a multiple choice question with 4 answer choices, right? Okay. Where is there a horizontal tangent? Okay, horizontal tangent is y prime equals 0, while x prime is not simultaneously 0. So y equals r sine theta. So y equals this times sine theta. So sine theta plus 2 powers of sine theta. Let's see, I've got a bunch more problems to do. All right. Okay, this chain rule, right? Sine theta squared, bring down, we'll deal with the outside first. The derivative of a thing squared is 2 times that thing to the first times the derivative of that thing. So, you know, we're multiplying the derivative of the square by the derivative of the sine, and that's what we're getting at. All right. Okay, and we want to know where is this equal to 0, and we can do this by hand because we can factor it. We can factor out a cosine theta, and we can be left with a 1 plus 2 sine theta. This is a good problem here. Okay, I know that cosine theta equals 0. I know where that happens. Okay, remember how to solve a trig equation once you get it down to cosine theta equals number, or sine of argument equals number. Doesn't have to just be theta. You go to the unit circle. You say, where is cosine equal to 0? It's here and there, where x is 0. So that's theta equal pi over 2 and 3 pi over 2. Yep, so in shot. Okay, so I'm going to collect my solutions over here. And then 1 plus 2 sine theta equals 0. Well, that's where sine theta is negative 1 divided by 2. And I'm, magnet on that. Okay, so I'm going to draw a unit circle. Say, all right, I'm interested in the y coordinate being negative 1/2, okay, which is kind of the first stop. Okay, it's the first thing bigger than 0. Half is not very big on the unit circle, is another way to say it. So from 0 to 2 pi, I've got, this is 7 pi over 6, and that's 11 pi over 6. Okay, those are the locations of the horizontal tangents on that graph. Okay, find the value of theta that corresponds to the point on the curve with x coordinate negative 1. That's, I'm assuming, this same curve. Yeah, it's, I mean, I don't know. I don't have anything else to go off of. So our cosine theta equals negative 1. So, and r is 1 plus sine theta. So 1 cosine theta plus cosine theta sine theta equals negative 1. I'm going to just real quickly think about what would happen if I pushed that 1 over to the other side. Factoring is only good when you've got the equation set equal to 0. Otherwise, it's not really useful. And so, let's see. Yeah, I'm just going to use a calculator to solve this equation, I think. And that'll be fine, right? Bring that in, and remember, to solve an equation you must be in function mode. So I'm over here and I am solving the equation cosine theta plus cosine theta sine theta equals negative 1. So plus 1 would need to equal 0, and I'm assuming we're on the interval 0 to 2 pi. Okay, there we go. Let's see, find the value. There's 2 places. Do something wrong. R cosine theta, 1 plus sine theta. X coordinate equals negative 1. I don't know. All right, so it looks like I found 2 solutions the last time I worked this homework, so it looks like it's between 1 and 2.5. And I get 2.146. Also, I'm going to get, calculate a 0, looks like it's between 2.5 and 3.5. And I get, oh, pi. Okay. Find the value of theta that corresponds to the point on the curve with y coordinate 3. Oh, it looks like I can pick this up in a minute. All right, so and now I need r sine theta equals 3. Okay, r is 1 plus sine theta, so r sine theta will be sine theta plus sine squared theta. Okay, and I am going to use the calculator to solve that equation because, well, we don't have a property. And sine theta plus sine theta squared, and I want it to equal positive 3, so I'm going to subtract 3 and find where it equals 0. And let's see, I bet it's, yeah, I got a good, oh no. Okay, let's look at the key from the previous year. No values of theta. Why? Just whatever. Doesn't happen. I think I should probably make that, I don't know, something where I subtracted less. I don't know. let down, but whatever. Last page. The function g is strictly positive for theta greater than or equal to 0. The polar graph of r equals g of theta is shown below. Graph's distance from the origin is increasing. All right, got to unpackage this. Distance from the origin. With that, they mean r. So r is increasing. I guess really distance from the origin is absolute value of r, but they told us that's why they said it's strictly positive for theta greater than or equal to 0, so we don't have to worry about where it was negative and decreasing. Which is polite of them. Okay, but in general, that's not a concern that you should have in AP calculus, right? The polar questions don't really go to that level, I've not found. Okay, so r is increasing. We know what makes a thing increasing, where its first derivative is positive. So I need g prime of theta greater than 0. So that's going to be theta squared minus 8 theta plus 15 is greater than 0. And if I were to factor that so as to draw a sketch and find where it was, where this thing is positive, I would have theta minus 5 and theta minus 3 is greater than 0. Okay? And so that is just to draw the graph of g prime of theta. That's a upward facing parabola with zeros at 3 and 5. Right, we know how to draw that. Looks like this. And so it's positive before 3 and after 5. So I would say theta is between 0 and 3, and theta is bigger than 5. Oh, it's 0 to 2 pi. Okay, so I'll just say 5 to 2 pi is when its distance from the origin is increasing. All right, the graph of r equals 1/2 theta plus sine of 2 theta is shown below. Find the value of theta that corresponds to the point on the curve in the second quadrant closest to the origin. Justify my answer. All right, so we're going to say, all right, second quadrant, that's a restriction on the domain, right? That's a closed interval. Second quadrant, so theta between pi over 2 and pi. Okay. And we want to minimize r subject to those constraints. That doesn't look good, but whatever. We're going to minimize r. So what we're going to do to run the closed interval test is we're going to consider the value of r at pi over 2 and pi, which I know you can tell it's happening at this minimum here. But you're going to need to at least justify that this is bigger than that distance there and that. So we got to check the endpoints. Okay, so we're going to check those endpoints, but, I guess we can do that. R is theta plus sine of 2 theta, and, what am I thinking? Oh yeah, I'm going to run pi over 2 and pi through that. So y1 with pi over 2 plugged in, and y1 with pi plugged in, and then I've got these numbers, so 0.785, pi was 1.571. Okay, now we want to know where r prime is 0, because if we want to maximize or minimize something, we take its derivative and set it equal to 0. So r prime equals 1/2 plus 2 cosine 2 theta. Okay, I'm not sure if this was supposed to be a no calculator question, but I'm just doing it with a calculator. So, I mean, you could... No, we do not know where cosine is 1/4. So yeah, this one requires a calculator for sure. So I need to know where this is equal to 0. Okay, so 1/2 plus 2 cosine 2 theta is equal to 0. And hold on. Yeah. And really, oh yeah, the window. 0.5 pi to pi. All right, there it was. There it happened. That was the place where r prime equaled 0. I'm going to go until, okay, over here where y is negative, go until y is positive. That will surround it. The 0 at theta equals 2.22230. Okay, and then we're going to take r of 2.230, and did I replace? I shouldn't have replaced. I should have put it into y2, but that's okay. Not a huge deal. I'm going to say is half theta plus sine 2 theta, and then I want to plug in y1 of 2.230. I get 0.147. Sure. Yeah. Okay. And so I'm going to, be explicit about my conclusion. Okay, it asks for the value of theta. So I'm going to say when theta equals 2.230. Okay. What is the maximum distance from the curve to the origin for 0 to pi? Luckily, we already computed r of pi. That was 1.571. Sounds like, I bet that's pi over 2, isn't it? Yeah, I see that. Anyway, and then r of 0 is going to be, that's going to also be 0 because 0 plus sine of 0 is 0 plus 0. All right. So didn't need to do that, but I'm going to, this time, I'm going to be a little smarter, and I'm going to, in y1, leave that, except I'm not going to graph it. In y2, I'm going to graph the derivative, because if I want the maximum distance from the curve to the origin, that's the maximum value of r. Okay. So I've got, what's going on here? Yeah, r prime equals 1/2 plus 2 cosine 2 theta, and that's equal to 0. Or I'm interested in where it might be equal to 0. And we're going to look from 0 up to pi this time. There's a place, and that looks like a maximum, right? That's a place where the derivative went from positive to negative. So I feel, okay, I'm going to calculate the 0. And now, notice we're asking for the maximum distance. So, to draw the comparison, in the first one, they said find the value of theta, and then now they're saying find the maximum distance. Okay, so that's going to make the difference in what I'm presenting as my final solution. All right, so I've got theta equals, and since theta is not the answer, I need to not be rounding off either. Okay, I need to keep all of those. Theta equals 0.9117383. Okay, since I computed that, it's got that stored into x for now. So I'm going to plug in on y1 with the point where theta equals x. Okay, because that x is that 0.911 number you can see. So 1.424. Okay, so r of 0.9117 ... is going to equal 1.424. What? Oh, yeah, I can see that. If you look at this, it does look like this is probably a little farther than it was over here. Okay, so it looks like it's going to be an endpoint maximum. Didn't even think about that. And then I also need to, there was a second place where the derivative equaled 0, right? This one. And you know it's a minimum, but your options are either just find it, find the coordinates, it's between 2 and 3, and, okay, yeah. Or just find it and run it through the candidates test. or you have to justify, in order to get the justification point on the free response questions that involve the absolute extrema, you have to justify the fact that you're excluding this theta value because it's a relative minimum, and you have to justify that it's a relative minimum. So it's just not worth it. We just check all of the critical points in my class. So R of 2.229 ... Well, we've already done that. That was 0.147. Okay, so the maximum distance is not that, it's the 1.571 number. Okay, so I will say maximum distance is 1.571. Okay, we're happy that. Right, the graphs of f of theta equals this and g of theta is that are shown below. Write an equation for d of theta where d represents the distance between the graphs of f and g. Ooh. Okay, so, oh, this is a good question. So if you think about it radially, which is how you should think about polar stuff, by radially I mean just like in terms of rays coming out from the origin, this distance here will be, that'll be the distance between the two curves. And it won't always be the shortest possible distance between them, but it's a standardized distance in terms of theta. So it's just going to be f of theta minus g of theta, I think. Let me see. I feel like the outside one's got to be f. Yeah, it's got to be g, because it's got the 12 and the 9. Because think about where sine hits 1, or sine hits -1, you got 12 plus 9 is 21. So, yeah, we've got stuff that's 21 units away from the origin somewhere over here. And that's going to mean that the outside one is g, and the inside one is f. So I've got d of theta equals g of theta minus f of theta. At what theta value do the two closest to each other? Probably pretty close to where I drew that little radius. So we're going to run an absolute minimum on these things from 0 to 2 pi, I would assume. All right, so let's just actually find d of 0, d of 2 pi, and the places where d prime equals 0. So I'm going to just start by typing this stuff in. So 2 plus, wait, it's g minus f. 12 minus 9 sine 2 theta minus, in parentheses, f of theta close parentheses. Right, window 0 to 2 pi. Let's see what happened. I am graphing g minus x. Okay, so the minimum distance looks like it might be happening twice, but we don't use the max min feature on our calculators. Not in a calculus class, right? Not if we want to get justification points. So we're going to go over here, and we're not going to be graphing this. We're going to be graphing the derivative. Okay, and I don't really want to sit and take all these derivatives right now, and probably the time I spent graphing the original would have been time I could have spent doing the derivative, but I'm going to do math 8. The derivative of y1 at the point where x equals x, and okay, that's a relative minimum. That's a relative maximum. That corresponds to right here. Here's another relative minimum. That's a relative maximum, but that corresponds to this point that's really distant. And so I'm going to calculate a 0. I'm going to ask you to forgive me for not, fully justifying my answer here, because I've got too much to compare. I got 0.749. In fact, I'm just going to eliminate d of 0 and d of 2 pi because, well, they'd be the same thing, first of all, because both of these are just on trig. sine of 2 pi is the same as sine of 0, and same all those things anyway. So I'm just going to exclude these and say, all right, theta equals d prime equals 0 when theta equals, what is it, 0.749. Okay. And also when theta equals, you can't see that, I'm going to calculate a minimum. That looks like it's about at 4, so maybe it's between 3 and 4. Yeah, 3.969. And that feels like, kind of somewhere around here where they're really close, and maybe over here where they're really close, right? Because 3.9, well, this is 3.14 radians here, so it should be close by. Anyway, I'm going to run these through d of theta, right? And so I'm going to quit and evaluate. Okay, right, y1 is d. So I'm going to run y1 of, 3.969, which I know is kind of rounded off, but it's all right. All right. And then y1 of 0.749. .974, which is bigger. Okay, so this is going to be my answer when they came closest to each other. .974. It's the average distance between the curves. That's the average value of d, so that's 1 over 2 pi minus 0 times the integral from 0 to 2 pi of d of theta d theta. Okay, average value of d. Okay, so I'm going to use the calculator for that. I'm going to do 1 over 2 pi. And you got to be careful about dividing by 2 pi with a calculator, right? Because if you aren't careful, the pi is going to get kicked back to the numerator, especially if you're working with a TI-83. 0 to 2 pi of d of theta was y1. Let it go. 10. Interesting. All right. Well, who knew? All right, and that's going to be all for this video. I think. Yeah, I've got an extra practice for this set, and it's more of like interpreting the meaning of the derivatives, like dy dx, dr d theta, dy d theta, dx d theta, r prime, f prime, theta, all those things. Are they positive, negative, or 0? It's a good set. If you're interested in more polar practice, you should have a look at that. But, thanks for watching.